All right, a quick review of absolute value equations and inequalities. The first thing you need to remember is the definition of the absolute value of a real number. The absolute value of a real number is its distance from zero. That's crucial to know that. Absolute value of a real number is its distance from zero on the real number line, regardless of sign or direction. All right, so let's go ahead and solve an absolute value equation. All right, so the first thing we're going to do is we're going to take a look at this equation and notice that the absolute value symbol needs to be isolated. 7 is being subtracted from the absolute value symbol, so to get the absolute value symbol alone on one side of the equal sign, we will add 7 to both sides. So we'll add 7, and we get the absolute value of x minus 3 is equal to 11. Okay, now remember this definition, distance from zero. How many places on the number line are 11 units away from zero? Well, there would be 2 places. Negative 11 is 11 units away from zero, and positive 11 is 11 units away from zero. So now what I want you to do is take what's inside this absolute value symbol and write it over the negative 11, because that what is inside there can either be equal to negative 11, or that x minus 3 inside the absolute value symbol could also be equal to positive 11. So when you do that, you can see there's kind of a visual here. You can see that to find our solutions, we're going to have to write 2 separate equations. Now, I had a student ask me today, do you always have to do that? And I would say once you get the hang of this, no, you don't. But in the beginning, to make sure you remember to write 2 equations, go ahead and write what's inside the absolute value symbol, write it above both places on the number line. So now let's go write our 2 equations. Either x minus 3 can be equal to negative 11, or x minus 3 could be equal to positive 11. All right, to solve for x in each equation, we're going to do it separately. We'd add 3 to both sides in the first equation, and we get x is equal to negative 8. And then over here, when we add 3 to both sides of the equation, we'll get that x is equal to positive 14. Now, anytime you solve an equation, you can always check your solution and make sure it's right. We're going to take each of these values for x, plug them into the original equation, and see if we get a true statement. So let's start with negative 8. When I plug it in right here, I would have the absolute value of negative 8 minus 3, finish that absolute value symbol, minus 7 is equal to 4. So all I did is I took this solution, plugged it right in for here for x. Now let's simplify so we have a true statement. Negative 8 minus 3 more would be negative 11 inside that absolute value symbol. All right. And then the absolute value of negative 11 is positive 11. And 11 minus 7 is equal to 4. That's a true statement, so we know this solution is right. Now let's check positive 14. So we're going to go back here. I'm not going to write it down this time. We're going to do this in our heads. Let's take 14, plug it in for x. 14 minus 3 is 11. The absolute value of 11 is 11, and 11 minus 7 does equal to 4, so this solution checks out as well. All right, so our 2 solutions to this absolute value equation are negative 8 and positive 14. All right then, let's move on to the absolute value inequalities. And just a reminder, this is a video. If you need to stop and watch any of this again or rewind and repeat things, please do that. But keep in mind, if you have any questions, you might want to jot them down somewhere, because likely if you have a question and you don't write it down, you'll forget it by tomorrow. So if you write that question down and ask me in class tomorrow, I'll be able to help you. All right, so now let's solve an absolute value inequality. Now you'll notice that this absolute value inequality has a greater than symbol. Okay, now this is kind of a goofy way to remember this, but when you see that greater than symbol, here's what I want you to think. I want you to think of this funny word, great or. So I purposely misspelled the word greater because I want you to remember when there's a greater than symbol, we're going to have to write an or statement. An or statement is called a disjunction. A disjunction is just two statements joined by the word or. Okay, so we'll talk more about that in just a second. But now what we're going to do is use this number line right here kind of as our thinking number line. So this number line is going to help us write our disjunction that we'll solve. We have another number line down here. That's where we'll put our final solution in the end. Okay, so let's think about this. The absolute value of 2x minus 1 is greater than or equal to 5. Now, remember, absolute value is distance from 0. So we're talking about something whose distance from 0 is greater than or equal to 5. So go down here on the number line, put -5 on your number line, and put +5 on your number line. Okay? And when we're talking about places on this number line that are 5 or more units away from 0, we would be talking about -5 and everything to the left. Okay, isn't everything that I've shaded more than 5 units away from 0? The other place that we could be 5 or more units away from 0 is over on the right end of the number line. So shade in 5 with a closed circle and then shade everything to the right. Okay, and what we've indicated here is all the numbers on the real number line that are 5 or more units away from 0. Okay, so now, like we did when we were solving equations, I want you to go back and take what's inside the absolute value symbol and write it above what we've shaded in. So put 2x minus 1 on the left end and put 2x minus 1 above the right end that we've shaded in. Now, by doing that, you can see that to solve this, we're going to have to write two inequalities joined by the word or. One of our inequalities will look like this. 2x minus 1. Now, we have 2x minus 1 on the left side of -5. So that would be less than or equal to -5, because all these numbers over here are less than or to the left of -5. So either 2x minus 1 is less than or equal to -5, or we can talk about this end of the number line, where 2x minus 1 is either equal to 5 or lies to the right of -5. So that would be greater than or equal to, I think I said -5, I'm sorry, I meant +5. Okay, so now we have two inequalities. Let's go back and solve them separately. So we'll add 1 to both sides in our first inequality, and we will get 2x is less than or equal to -4. And then to solve for x, we're going to divide both sides by 2. Now, since I'm dividing by a positive, that has no effect on the inequality sign. It stays less than. So we have x is less than or equal to -2. Okay, that's part of our solution set. But we still have to go back and solve this inequality. So follow the same steps. We're going to add 1 to both sides. And we get 2x is greater than or equal to 6. Divide both sides by 2. And we get x is greater than or equal to +3. Again, oops, sorry about that. We divided both sides. There we go. We divided both sides by a positive number, so we did not reverse that inequality sign. Okay, so let's join those two inequalities with the word or. Let's draw a box around the whole thing. There's our solution set. Any number that's either less than or equal to -2 or greater than or equal to +3, if we would take any of those numbers, put them in for x, it would make a true statement. Okay, so the last thing we're going to do is draw a picture of our solution set on this number line here. So we've written it as a disjunction, two inequalities joined by the word or. But let's go ahead and indicate that solution set on our number line. So let's put -2 on our number line. And we're going to put a closed circle on -2 because of this less than or equal to symbol, and then shade everything to the left. Remember, less than means lies to the left of on the number line. We're also going to put +3 on the number line, put a closed circle because of this greater than or equal to symbol, and then shade everything to the right because these are the numbers that are greater than 3. That means lies to the right of 3. All right, so there we have an absolute value inequality that involves a greater than symbol. Now, let's do one more review problem. All right, this absolute value inequality has a less than symbol. Okay, so this is kind of goofy, but when you see that less than symbol, here's what I want you to think. I want you to think less, less than. Okay, because when there's a less than symbol, we're going to be writing two inequalities this time joined by the word and when we do that, write two inequalities joined by the word and, that's called a conjunction. Okay, we'll talk more about a conjunction in just a minute. All right, so this first number line again is kind of our thinking number line. Okay, let's think about all the places on the number line that would be fewer than 12 units away from 0. All right, so we're going to need to put negative 12 on our number line and positive 12 on our number line. And what numbers are fewer than 12 units away from 0? Well, that would be everything in the middle here, right? I'm going to put an open circle on negative 12 because of this strictly less than symbol, and an open circle on positive 12, again because of the strictly less than symbol. And then I'm going to shade in all the numbers in between, because what I'm shading in here are all the numbers that are fewer than 12 units away from 0. All right? Now, just like we did on the last two examples, take what's inside the absolute value symbol, and I want you to write it above what we've shaded in. Now, we only need to write it once this time, because we're not on the ends of the number line. We're talking about the middle of the number line. Okay, so now it's time to write our two inequalities joined by the word and. Okay, so take a look at your picture. 6x is at the same time bigger than negative 12 and less than positive 12. So let's write those two inequalities. 6x is greater than negative 12 and at the same time, and at the same time, 6x lies to the left of positive 12, so we'd write 6x is less than 12. Okay, now solving these two inequalities, we'll take one step each. We'll divide both sides by 6. I'm dividing by a positive, so that has no effect on the inequality sign. So x is greater than negative 2, and at the same time, when we divide both sides by 6 in our other inequality, we see that x is less than positive 2. All right, join those two statements with the word and. Let's draw a box around that because that's our solution set. All the numbers that are at the same time bigger than negative 2 and less than positive 2. So we've written our solution set as a conjunction. Let's go ahead and indicate our solution set then down here on our number line by putting negative 2 on the number line, positive 2 on the number line, open circles on both of those because of the strictly greater than and strictly less than symbol. And then we're going to shade in everything in between, because what we're shading, sorry, this isn't a very good job of shading. What we're shading is all the numbers that are at the same time bigger than negative 2 and less than positive 2. Now I want to show you one more quick thing, and that is whenever we have a conjunction, this only works when we have a conjunction, a less than symbol. If you want, instead of writing two statements joined by the word and, we could also write a compound inequality. All right, take a look at this. 6x. It is at the same time bigger than negative 12 and less than positive 12, all at the same time. So instead of writing two statements, we could write that as one compound inequality. So we're going to put negative 12 on the left, positive 12 on the far right, and 6x in the middle. Now, we need inequality signs here and here, so think about what would make sense. Negative 12 on the left, positive 12 on the right. The only inequality sign that makes sense is to put a less than symbol right here and a less than symbol right here. When you write compound inequalities, you want to make sure that your inequality signs both face the same direction. Okay, so now isn't this a picture of exactly what you see on this number line? See how 6x is at the same time to the right of negative 12 and to the left of positive 12? So we can write that all in one step with a compound inequality. Now, when you go to solve a compound inequality, solve it like you solve any other equation or inequality. Look at the variable. I want to get x all by itself. X is being multiplied by 6, so we'll divide everything and every part of the inequality by 6 to get that x by itself. So negative 12 divided by 6 is negative 2. That is less than, these 6's will cancel, so that's less than x, which at the same time is less than positive 2. And isn't this expression, or this compound inequality, exactly what you see right here on this number line? All the x's that are at the same time bigger than negative 2 and less than positive 2. All right, so there's a quick review of absolute value equations and inequalities. If you have any questions, be sure and let me know tomorrow in class.